These are your notes for Unit 13, Day 4 of Pre-Calculus. If you would like to see your warm-up, your review question, or any homework questions we covered in class today, just look at the finished notes. So today we're going to continue talking about statistics. We're going to talk about a new way to organize data, which is called a box plot. And in order to do that, we're going to talk about a thing called the 5-number summary. So our quartiles and how to find quartile 1, 2, and 3. How to find an IQR was the interquartile range, or define the standard deviation, which is another way of talking about how data varies off of the mean. And how do we find official outliers? So not just numbers that look like they're far away from the rest of the numbers, but what would actually be classified as an outlier. So the 5-number summary process. So how do we find things called quartiles, the median, the range, and the IQR? So our first step to create a box plot is we're going to take our data and we're going to put it in order from least to greatest. So the smallest number out of all of our data looks to be 6, and then we have a 7, so 6, 7, and then we have an 8 and a 9, and then it looks like we have 2 10s, and then we have a 12, a 13, 2 15s, and then, oops, we missed a 14. So a 14, 2 15s, and then a 22, a 29, and a 35. 22, 29, and 35. So the quartiles, we're going to basically divide this data into 4 sections. And in order to do that, we're going to find the mean, which would divide the data in half. And then we're going to find the median, which would divide the data in half. And then we're going to find the median of each of those halves. So we're going to call those numbers Q1, Q2, and Q3. And it's going to divide our data into fourths. So to find the median, remember we just go through and we find the middle number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 9. Oh, there were 2 10s. That's what this happened. So there's 2 middle numbers. So my Q2, which is going to be the median, you add those together and divide by 2. So my Q2 is going to be 12.5. So now I took that data set and I divided it in half. So now I have the first half of my data and I have the second half of my data. So now the data is divided into 2 halves. So now we're going to find the median of each of those halves. So let's find the median of each of those halves. So if I found the median of the first half, I would have 9. So 9 is going to be what we would call Q1. So it's going to be the median of that quartile. So notice now I divided the data into 2 more sections. So I have this quartile and this quartile. And Q1 divided that lower quartile into 2 sections. Q2 divided the whole data set into 2 sections. And then we're going to look at the upper quartile. So 13, 35, 14, 29, 15, 15. So 15 is going to be what we call Q3. And that's going to be the median of the upper quartile. So this is the median of the upper quartile. And then Q1 is the median of the lower quartile. So we've divided our data into 4 sections, hence the quartiles. So the median is the middle number. Q1 and Q3 are the median of the upper half, the median of the lower half. Sorry, not quartile, upper half and half. Lower half. And then the range is going to be the highest number minus the lowest number, just like normal. So it'll be 35 minus 6. So my range of numbers is 29. And then you have something called the IQR, which is the interquartile range. And that is going to be Q3 minus Q1. So in this case, it's going to be 15 minus 9. So it's going to be 6. So my IQR, the interquartile range, which is also going to help us find outliers, is going to be Q3 minus Q1. So now if we actually want to make a box plot, we kind of think of it like on a number line. So on my number line, I'm going to go from 6 to 35. So 6, and then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So that is going to be my highest and lowest number. And then we put in our quartiles. So Q1 is 9, so 7, 8, 9. So here's Q1. And then Q2 is 12.5. So 10, 11, 12.5. So 12.5 is Q2. And then Q3 is 15. So 13, 14, 15. So here is Q3. And then we put a box around those numbers. Oops. And we put a line through the box. So notice you have a box, and then the numbers from the min to the max, you can put whiskers on it. So this is also called a box and whisker plot. So it kind of shows you the spread of the data. Now, if you want to know if a number is an outlier, we use the IQR. So notice it looks like 35 probably is going to be an outlier. So if you want to know if something's an outlier, we have an actual mathematical calculation we can do. We can do Q3 plus 1.5 times the IQR. If any numbers are greater than that, they would be an outlier. Or you could do Q1 minus 1.5 times the IQR. If any numbers are smaller than that, they'd be an outlier. So in this example, Q3 is 15. So if I did 15 plus 1.5 times the IQR is 6, we would get 15 plus 1.5 times 6, I get 24. So any numbers bigger than 24 would be outliers. So I actually have two outliers. 29 and 25 are both going to be outliers. And then any numbers smaller than, we're going to do Q1, and in this case Q1 is 9, so 9 minus 1.5 times the IQR. So 9 minus 1.5 times the IQR, which is 6, would be 0. So any numbers smaller than 0 would also be outliers. So in this problem, you have two numbers that are outliers that really don't fit in with the rest of your data set, and they'd be 29 and 35. And so this is called a box plot or a box and whisker plot. So you do a 5-number summary process. You find Q1, Q2, Q3, the range and the IQR, and then you can use that to draw a box plot or a box and whisker plot. So let's look at another example. How many points do teams score in the Super Bowl? Listed below are the past 22 Super Bowl combined scores between 1999 and 2020. So let's go ahead and make a box plot of this data. So we're going to arrange these. Well, we can actually use our Snaplet.com to do this as well. So quantitative, one variable. Whoops. There we go. Super Bowl points. And then we're going to enter in raw data. So 53, 39, 41, 37, 45, 31, 46, 31, 50, 48, 56, 38, 65, 51, 52, 34, 62, 74, 16, and 51. All right, and then if we did a box plot, notice it's going to make our box plot for us. So here we go. So it looks like it's not giving us it exactly, but notice it's the range looks between before 74 and maybe 16. And it looks like Q1 looks to be about 37. Q2, the median, looks to be about 48, 49. And Q3 looks to be about 56, 57. So let's do this by hand and see if we get a similar looking picture. So the smallest number looks to be 16. And then any in the 20s? Nope. So in the 30s, so 31, 31, 34, 37, 38, 39, and then we've got 45, 46, 48, and then we've got 50, we've got 51, 52, we've got 53, oops, I missed a 41, we've got 53, we've got 56, we've got 61, 62, we've got 65, oops, we missed 51, there are two 51s, there were, 65, 69, and then 74 is the highest. So let's start by finding the median. So cancel, 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 cancel. So 48 and 50 look to be in the middle. So my Q2 is going to be 49. So that's my median. And then my Q1 is going to be the median of the lower half. So that is going to be 38. So Q1 is going to be 38. And then Q3 is going to be the median of the upper half. So uh-oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah. 56, hopefully. 1, 2, 3, 4, 5, yep. So 56 is going to be Q3. And then my range is going to be max minus min, so 74 minus 16, which is going to be 58. And then the IQR is going to be Q3 minus Q1, which is going to be 56 minus 38, which is going to be 18. So the IQR is going to be 18. And so now if I make my box plot, I'm going to go between 16 and 74, and then 38, and then 49, so, and then 56. And notice this isn't going to be 100% accurate. And then you've got whiskers out to 76 and 16. So there is my box plot. And if you want to know, are there any outliers, you would do Q3 plus 1.5 times the IQR. Or you would do Q1 minus 1.5 times the IQR. So are any of my numbers outliers? Well, Q3, well, do Q1. So 38 minus 1.5 times the IQR is 18. So 11 would be an outlier, but the smallest score was 16. So there's no small outliers. And then Q3 was 56. So 56 plus 1.5 times the IQR, which was 18. Whoops. So any number is bigger than 83. So there are no outliers in the Super Bowl data. And that is how you could make a box plot or a box and whisker plot. So another way of analyzing data is finding something called the standard deviation. So the standard deviation is how much your data set deviates from the mean. So if you found the average, so let's say on average in a basketball game, When you play, you score on average 18 points. But then you have a standard deviation of 5. That means that on average you score 18 points, but that can vary 5 more or 5 less on any given day. So technically your range of what you typically score would be, you typically score 18, but it could average anywhere between 13 and 23 would be within the scale of what's normal. So that's called the standard deviation. Or if you bought a new set of tires, and let's say your new set of tires on average last 50,000 miles, but you're looking at 2 different types of tires, and one has a standard deviation of 10,000 miles, and the other one has a standard deviation of 2,000 miles. It also talks about how reliable those tires are. One that has a standard deviation of 10,000 miles means that, yeah, the mean is they last on average 50,000 miles, but that can vary 10,000 miles more or less given the set of tires. Or the other set of tires would be, on average, it varies 2,000 miles. Those are a more reliable pair of tires based on their standard deviation. So how do we find the standard deviation? Well, your steps are, you're going to find the mean, and then you're going to find the variation for each number compared to the mean. So you'll take the mean minus that data point, and then you're going to sum all of them and average it. So here's a data set to try out. Here are foot lengths in centimeters for a random sample of 7 people, 7 14-year-olds from the United Kingdom. So we have 25, 22, 20, 25, 24, 24, and 28. And those are how long their feet are in centimeters. So we are going to find the mean of that data set. And notice the mean is going to be 24, but if we were to find the mean, average, add them all together and then divide by the total. So 25 plus 22 plus 20 plus 25 plus 24 plus 24, 25 plus 22 plus 20 plus 25 plus 24 plus 24 plus 28 divided by 7, and we've got 5. So 25 plus 22 plus 20 plus 25 plus 24 plus 24, plus 28. There we go. So the mean is 24. So we found the mean. The mean is 24, and we call that X bar. So that's called X bar, and the mean is going to be 24. So the mean is 24. So now you're going to take each individual data point. So Xi is going to represent each individual data point. And you're going to figure out how each individual data point varies from the mean. So you're going to subtract it. So 25 minus 24, because my data point was 25, the mean is 24, so subtract them. 22 minus 24 is going to be negative 2. 20 minus 24 is going to be negative 4. 25 minus 24 is going to be 1. 24 minus 24 is 0. 24 minus 24 is 0. 28 minus 24 is 4. So now what we're going to do is we are going to notice how some of them are negative. To deal with the negatives, we're going to square all of those. So we're going to do 1 squared, which is 1. We're going to do negative 2 squared, which is 4. We're going to do negative 4 squared, which is 16. We're going to do 1 squared, which is 1. 0 squared, which is 0. 0 squared, which is 0. And 4 squared, which is 16. And now we're going to add all of those together. And so if we add all of those together, we get 1 plus 4 plus 16 plus 1 plus 0 plus 0 plus 16. So the sum of all of those is going to be 38. And then we are going to average them. So 38 divided by 7. And we get 5.42857. All right, so that's called our variance. So the variance of our data set is 5.42857. And now if you take the square root of that, so if you take the square root of the variance, you're going to get your standard deviation. So if I take the square root of that data set, oops. Well, we'll just take the square root of 5.42857. 542. And you get 2.3299. So that is going to be the standard deviation of my data set is 2.3299. So my mean, my X bar, is 24. So on average, for those 7 14-year-olds from the United Kingdom have a shoe size of 24 centimeters, but that could vary 2.33 centimeters from kid to kid on average. So that's the meaning of that. All right, so let's go ahead and find the standard deviation of the 2004 Cincinnati Bengals scored 24, 16, 9, 17, 17, 23, 20, 26, 17, 14, 58, 27, and 28 points in their first 13 games. Find the mean and the standard deviation of the data. Identify any outliers and describe how it affects the mean and the standard deviation. All right, so let's do our score. And so we had 24, 16, 9, 17, 17, 23, 20, 26, 17, 14, 58, 27, and 28. All right, so we're going to find the mean of that data set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 games. Let's add up all their scores. So we had 24 plus 16 plus 9 plus 17 plus 17 plus 23 plus 20 plus 26 plus 17 plus 14 plus 58 plus 27 plus 28. So 296, and then divided by, did I say 13? 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. So X bar is going to be 22.769. So that's going to be our mean. So our X bar, our individual data point minus X bar. And then we're going to square it, and we'll just do all of that at once. So 24 minus 22.769 squared, and this is going to be 1.515361. And then we'll do 16, and we get 45.819361. And then we're going to do 9, and we get 189.585. And we're going to do 17, and we get 33.281, 33.281. And then we'll do 23, and we get 0.053361. And we'll do 20. We get 7.667361. We'll do 26. we get 10.439361. And then we already did 17. We got 33.281. And then we're going to do 14. We get 76.895. We'll do 58, which is the outlier. And we get 1241.2233. We'll do 27. And we get 17.901. And then we'll do 28. And we get 27.3633. All right, so now we're going to sum all of those. So 1.515 plus 45.819 plus 189.585 plus 33.281, plus 33.281 plus 0.053361 plus 7.667 plus 10.43 plus 33.281 plus 76.895. I'm going to leave that big one to last. 17.901 plus 27.3633, and then plus the big one, 124.22, and then we're going to divide that by 13, and that's going to give us our variance. So our variance is going to be 132.176, and then if you take the square root of that, so the square root of 132.176, my standard deviation is going to be 11.5. So it looked like in 2004, the Cincinnati Bengals scored on average 22 points, but it give or take 11.5 points, which is a huge spread of data. But they had that outlier. In that one game, they scored 58 points, which is an outlier. So if we got rid of the outlier, which was the big number in this guy, so let's go all the way to the end and get rid of that outlier number. And then instead of dividing by 13, we'll divide by 12. So let's go all the way to the end. So we're going to get rid of that last number. And then we're going to divide by 12 if we got rid of it. So then the variance would be 39. So if we got rid of the outlier, the variance would be 39.76. We'll round up. And then if we took the square root of that, 39.76. My standard deviation, if I got rid of the outlier, would be 6.3. So on average, well, we would also have to get rid of the biggest number here. So let's get rid of the 58 here. And then, so if you got rid of the 58 points, then the Bengals scored on average 19.8 points a game, and their standard deviation was 6.3 if we got rid of the outlier. All right, so that's standard deviation. Your homework is